Hello everyone. This video demonstrates how to test the reference design for Linux Jailhouse Hypervisor Virtualization on the Sitara AM572X ARM plus DSP processor. This reference design is intended for embedded applications that require the integration of a real-time component built using either bare metal or RTOS, and a Linux component that provides cloud connectivity or a graphics interface. For additional details, download the reference guide for this TI design at the link shown. Jailhouse is an open-source, static partitioning hypervisor that runs bare metal binaries. It cooperates closely with Linux. Jailhouse does not emulate resources that do not exist on the hardware. It just splits existing hardware resources into isolated compartments called cells. One of these cells runs the Linux operating system and is known as the root cell. Other non-root cells borrow CPUs and devices from the root cell as they are created. These non-root cells are called inmates. Before we begin the demonstration, let's take a high-level look at the Jailhouse hypervisor initialization process. The AM572X has two ARM15 cores. Upon initial boot, Linux uses both the ARM cores. After enabling Jailhouse Hypervisor, Linux moves to the root cell, which still uses both ARM cores. When a new cell is created for the inmate, Jailhouse Hypervisor calls CPU_down for the ARM1 core, leaving Linux on ARM0 only. The new cell uses the ARM1 core and hardware resources dedicated for this cell as defined in the cell configuration file. Now let's proceed to the demonstration. First, we will set up the hardware. Next, we will install all required software and prepare the SD card with pre-built images. We will then boot the boards with the SD card installed. Finally, we will start Jailhouse and then verify that both the root cell and the inmate are functioning. Let's begin with the hardware setup. This Jailhouse hypervisor demonstration runs on both the AM5728 EVM and the AM5728 Industrial Development Kit, also known as IDK. In this video, the AM5728 EVM is used. The host can be a Windows or Linux machine equipped with both Ethernet and USB. A Telnet and serial port console program, such as PuTTY, is required on the host. First, connect both the EVM and host to the same Ethernet LAN. Then, connect the EVM to the host using a USB to micro USB cable. Check which COM port becomes visible when the USB cable is connected from the host. In this example, COM3. Then, open a console on the host with the terminal emulator parameters shown. All the required Jailhouse software is available within Processor SDK Linux starting with the release 4.0 and can be run using the pre-built SD card image. For purposes of this demonstration, it is assumed that you have already installed and booted Processor SDK Linux on the AM5728 EVM. Jailhouse consists of three parts: kernel module, hypervisor firmware, and tools, which a user uses to enable the hypervisor, create a cell, load inmate binary, run, and stop it. Each of these Jailhouse software elements can be found in the directories shown. The boot arguments need to be modified in order to use Jailhouse. First, we will modify the boot arguments to increase the contiguous virtual memory from 240 megabytes, which is the default, to 512 megabytes. Next, we will modify the boot arguments to identify the correct device tree for the EVM being used in the demonstration. Okay, so we have now booted the AM5728 EVM with the Processor SDK Linux 4.0 pre-built SD card. Let's check the memory arguments using the command cat/proc/meminfo. Note that the total amount of virtual memory allocated is 240 megabytes, which is the default. Let's reboot the board and then halt the boot to access the U-boot shell. Now, let's modify the boot arguments using the command printenv args_mmc. First, we modify the boot arguments to allocate more virtual memory using the command setenv args_mmc with the parameters shown. Next, we modify the boot arguments to identify the correct device tree using the command setenv findfdt with the parameters shown. In this case, the device tree for the AM5728 EVM is AM572X-EVM-jailhouse.dtb. Once the boot arguments have been modified, store the modifications with save-env and continue the boot process. After the boot process is complete, log in and check the memory arguments. As you can see, 512 megabytes has now been allocated to virtual memory. We are now ready to begin the Jailhouse demo. The commands shown are used to insert the kernel module, enable the hypervisor, create a cell for the inmate, load the bare metal binary, and start the binary. Open a telnet window on the host to access the EVM and start Jailhouse. First, let's insert the kernel module using the modprobe jailhouse command. Next, we enable the hypervisor using the jailhouse enable command. This initializes the hypervisor. We then create a cell for the inmate using the jailhouse cell create command. CPU 1 is shut down and the cell is created. Then, load the bare metal binary using the jailhouse cell load command. The cell is now ready to be loaded. Finally, we start the binary using the jailhouse cell start command. As you can see, the cell is now started. Now let's validate that everything's working. The bare metal example application is now running on Core 1 and owns the UART, a timer, and related interrupts. Linux continues to run utilizing CPU 0 and has control over the rest of the AM5728. This can be verified by launching any of the examples from the Matrix user interface, which will run in parallel to the inmate. This concludes the demonstration for Linux Jailhouse Hypervisor virtualization on the Satara AM572X. For more information, refer to the links shown. Thank you for taking the time to watch this demonstration. If you have any questions, please post them on the Texas Instruments EDE forum at ede.ti.com.